Measures of spread are descriptive statistics or summary statistics and fall under the data analysis step in the statistical investigation process. Generally, the first descriptive or summary statistic looked at is a measure of centre, but alone this can be misleading. A useful numeric description of a distribution requires both a measure of centre and a measure of spread. Imagine the lines here represent the distribution of 3 golf players' scores on a number line, and the colours represent each player. The green, red and yellow players all have the same mean, but clearly they have different spreads. Most of the green players' scores are close to their mean. In contrast, the yellow player has a wide range of scores that are spread out from the mean score. You could say that the green player is more consistent than the yellow player. In this video, we'll look at the range, the 5-figure summary, including minimum value, the first quartile, median, third quartile, maximum value, and the interquartile range. The first measure of spread we're going to look at is the range. The range is simply the difference between the largest or maximum value and the smallest or minimum value. In other words, you subtract the minimum value from the maximum value. The range is easiest to find if you have ordered your data set, as you can easily identify the minimum and maximum values. If you've identified the median in measures of centre, you should have already done this. The range is not considered a particularly reliable measure because it only uses 2 data values. It may be influenced by data values that are extremely low or extremely high, known as outliers. Let's find the range of this data set. Remember, the range is the maximum value minus the minimum value. First, we rearrange the data into ascending order. Then we can calculate the range. As you can see here, the range is influenced by what appears to be an outlier. So let's calculate it. If we remove that outlier, the range will reduce to 12, which is very different to what we get when 45 is in the data set. This number is impacting the reliability of the calculation. We'd need to investigate further to confirm whether 45 should be included. Outliers are discussed further in my outliers video. Data can be ordered and divided into 4 regions that cover the total range of observations. These regions are known as quartiles. The median divides the ordered data into a lower and upper half. The lower quartile is the median of the lower half. The upper quartile is the median of the upper half. To find the quartiles, we arrange the observations in increasing or ascending order. Locate the median, which is the middle number for an odd number of values, and the mean of the middle 2 numbers for an even number of values. Then we locate the lower quartile, which is the median of observations to the left of the median. And then we locate the upper quartile, or Q3, which is the median of the observations to the right of the median. The minimum and maximum values alone tell us little about the distribution as a whole. Likewise, the median and quartiles tell us little about the tails or ends of a distribution. To get a quick summary of both centre and spread, we review all 5 figures. The 5-figure summary consists of the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. The lower quartile is above 25% of the data values, and therefore below 75% of the data values. The median is above and below both 50% of the data values, and the upper quartile is above 75% of the data values and below 25% of the data values. Let's find the 5-figure summary for this data set. So first, we arrange it in increasing or ascending order. The minimum value is 43. The maximum value is 88. They're easy to identify. Then we locate the median, or Q2. It's 75 in our example here. If there's an odd number of values, remove the median before calculating Q1 and Q3, or your lower quartile and upper quartile. Another way to think about it is that if the median is a data value, we ignore it and split the remaining data into 2. So we ignore the median, which splits the rest of the data into 2 sets. The lower quartile is the median of the observations located to the left of the median. The upper quartile, Q3, is the median of the observations to the right of the median in the ordered data set. Let's find the 5-figure summary for this data. Arrange the observations into increasing or ascending order. The minimum value is 11, the maximum value is 45. locate the median, or Q2. Because we have an even number of values here, we take the mean of the two values in the middle of the data set, and that is 16. If there's an even number of values, keep the middle value before calculating Q1 and Q3. Technically, because we calculated the median is not one of our original data values and falls in between 16 and 16 here, and I've highlighted that here in yellow. The lower quartile, Q1, is the median of the observations located to the left of the median. And that, in this case, we have to take the mean of 12 and 14 because that's the median of the lower half of the data. The upper quartile, Q3, is the median of the observations to the right of the median. In this case, 20 and 22. So we take the mean of those values and we get 21. So Q3, or the upper quartile, is 21. The second measures of spread we're going to look at is the interquartile range. Now we know how to find the quartiles, we can calculate it. The difference between the upper quartile and the lower quartile is called the interquartile range. That is the upper quartile minus the lower quartile. Another way to write it is Q3 minus Q1. Let's find the interquartile range for this data set. The interquartile range is the upper quartile minus the lower quartile. First, we need to order the data again, find the median at 75. Because we have an odd number of values, we exclude the median. Find the lower quartile, which is the median of the lower half of the data, or the data to the left of the median. Then we find the upper quartile, or Q3, which is the data to the right of the median, or the upper half. And the interquartile range is Q3 take Q1. And we know that's 82 take 67. And we get the interquartile range for this set of data is 15. Let's find it for this set of data. So the interquartile range, upper quartile take lower quartile. We have to order the data set first. And then we find the median. And we do that because we need to split the data into two halves. And now we find the median of the lower half and the upper half. The median, or Q1, which is the lower quartile of the lower half, is 13. And the upper quartile, or Q3, is the median of the upper half of the data, and that's 21. Now we can work out the interquartile range, which is Q3 take Q1, and the interquartile range for this set of data is 8. Another thing we might be asked to do is to find the value that, or the percentage of data that falls above or below. Here we are asked to determine the value that 25% of data is above. 25% of data is a quarter, and we know that the quartiles split our data set into quarters. The upper quartile, or Q3, is above 75% of the ordered data and below 25% of the ordered data. Therefore, 25% of our data is above Q3, or the upper quartile, which is 21. Here we are asked to determine the value that 50% of the data falls above and below. We know that the median splits the data into two halves. Therefore, 50% of the data below the median falls below the median, and 50% of the data is above the median. Therefore, the answer is Q2, which is 16. So 50% of data values fall above and below Q2, or the median. In summary, in this video, we've had a look at the range, the 5-figure summary, including the minimum, first quartile, or lower quartile, median, third quartile, or which is the upper quartile, the maximum value, and the interquartile range. Thank you.